Hello and good morning, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP switch course, CCNP route course, and this morning's video tutorial is going to be on the AS path attribute in BGP. We're also going to be taking a look at what we call AS path access lists, where we create an access list, but instead of basing it on maybe a source prefix or a destination prefix, we're going to be creating an access list that is based on the AS path numbers that we see. So here is our setup. Some minor changes. The IP addresses have changed a little bit. This is identical to lab 7.1. Let me undo the move there. This is identical to lab 7.1. But the IPs have changed, the autonomous system numbers have changed. In fact, as I'm looking at this, it looks like I failed to update the AS number of the Evil Corp ISP. So we're going to go with the Evil Corp ISP here as AS300, and this is actually 65,000. There we go. All right, but other than that, everything else is the same as Lab 7.1 in terms of the physical layout. So we've got some minor changes with respect to the autonomous system numbers and the IP addressing scheme. You can see that this is the International Travel Agency office located in Santa Rosa, California. We've got the Evil Corp ISP, and then we simply have customer A over here who is connected to the Evil Corp ISP. So this is it's not a customer of the International Travel Agency. This is a customer of ISP, or the Evil Corp ISP. So all of the basic IP addressing is configured. Let's dive into the command line here and get BGP set up and ready to go. So we'll go from user exec to privilege exec into global config, and remember that the Santa Rosa router is just simply going to be router BGP 100. So now we need our neighbor statement, right, so that we can establish that BGP peering. The neighbor is going to be 192.168.1.6. And the remote AS for the Evil Corp ISP is going to be remote autonomous system number 300. So now we're going to originate some NLRI here, right? Or in other words, a network. So 10.1.1.0, we're going to originate this with the network command, and then we're going to say mask 255.255.255.0. All right. So we've got the Santa Rosa router configured and ready to go in BGP Autonomous System 100. So let's go ahead and say end. And now let's jump on to the Evil Corp ISP, who in our setup here is going to be router 2. So we're going to go from user exec to privilege exec into global config. Simply say router BGP 300. Now we're going to need a couple of neighbor statements here, because remember the ISP also has customer A over on the side there. So 192.168. What did we say? 1.5, and the remote AS. So who is this neighbor statement for? Exactly, that neighbor statement is going to be for the International Travel Agency in Santa Rosa, California. And there you can see that we actually have the debug is still on here. I think we're debugging the updates do show what is it? Debug. So yeah, we're debugging the updates. So you'll notice though that we picked up the NLRI, we received this NLRI, and here the update came in. And again, very, very simple with just that debug IP BGP update command to see the attributes that come through in a debug. Now, if you're receiving thousands of updates, might not be the most realistic or the best way to go about it, but you know, we're very inductive approach here, going very simple examples and then increasing the complexity. But as you can see here, we get all of that AS path information here, right? You can see we get the AS path here. It shows us it's coming the merge path 100. And we get the well-known mandatory attributes. The next hop is well-known mandatory. The origin, pull it back here, the origin, I, right, meaning IGP, which was originated with a network command, and then the AS path. Those are your three well-known mandatory path attributes. So now let's go ahead and finish out the R2 Evil Corp ISP config by putting in that 172.24.1.18 neighbor statement. Now let's remember here that this is a private autonomous system number, right? So we're going to see here in a little bit, we're going to have some possible issues that we need to address from Evil Corp ISP's perspective when we are giving or when we're peering with customers that are going to be using private autonomous system numbers. Because remember, the private autonomous system numbers should never be seen on the publicly routable internet. All right, and so then the Evil Corp ISP is also going to originate the following network, the 10220. All right, and you can see we've got our update there, and then that is it right now for the Evil Corp ISP. So if I were to say show IP, show IP BGP, you can see a couple of things here, right? And again, it's very, very helpful to take an inductive approach and work with small data sets initially and then grow those data sets out. So let's address this first entry that we have here. You can see the third column is blank, and so if that third column is blank and the next hop and the wait are not quad zeros and 32768, this is implicitly an E. Right? Now you'll notice the status codes up here. There is no E status code. There's only, when we're talking about eBGP or iBGP, there's only an I. So there is no E up here. And again, remember, this is an implicit E. Whoops, pen died out on me there. Implicit E, meaning in terms of the status code that it was learned from an eBGP speaker. So here's the NLRI, or that network layer reachability information, is the 10110/24. The next hop, right, another well-known mandatory attribute, and that's a 192.168.1.5. Simply the next hop IP address. This is of router 1, the ITA router, and that's that serial link. The MED, remember the MED by default will be 0 here. Local preference is actually 100. Remember, when we do that show IP BGP and we put the prefix or the NLRI in there, you will see that the local pref is 100 because that is the default. It doesn't show it here, but it is set to 100. The wait column, you can see the wait is 0. So the wait is always 0 on iBGP or eBGP learned route. So if we learn it from an eBGP neighbor or if we learn it from an iBGP neighbor, the wait is going to be 0. And the reason that I can say that is because, remember, wait is a local Cisco proprietary setting. It is not a BGP path attribute. And the reason I say it's not a BGP path attribute, it is not communicated in any update messages. So it is 100% locally significant on the router on which it's set. And then we have our AS path column. You can see that this NLRI, the 10110/24, originated in Autonomous System 100. Now we get to the origin code. Remember, sometimes it can be confusing. If this was learned from an iBGP neighbor and it was originated with the network statement, then we would have I's on both sides, right? You'd have an I in the status code column, and we would have an I here in the origin code column. And the tough thing is always remembering that there is no header here, right? I never figured out, maybe it's because the AS path is a variable length, that they didn't put the origin code header in. But again, remember, the origin code is over here on the far right, and the origin code will be one of 3 values. And in our studies, it's really going to be one of 2 values. It's either going to be the I or the question mark, right? The I meaning that it was originated with the network command. And so here, let me explain that real quickly. So when you use the network command, it means that you have that NLRI in your global rib. And that's what it means by IGP, is that it was in the global rib. We use the network command. The incomplete, or the question mark, it means that we redistributed it into BGP. So I can't conclusively tell you where that routing information came from because it was redistributed in, right? And that's where we end up with the question mark for the incomplete. But again, here we see we have the I's because we use the network statement both locally as well as the International Travel Agency router that originated this NLRI originated it with the network statement. And so that's just a basic walkthrough again. Mastering this output right here is going to be very, very critical in terms of your BGP skill set. So let's go ahead and clear the screen, and we'll get control back of the cursor. All right, so we're on the EvilCorp ISP router here. So let's go now configure the customer router. And so we're going to go into global config here. We're going to say router BGP 65000. Now, whoops, okay, let's say no router BGP 300. We have the legacy from lab 7.1, but we just got rid of that. So now let's rerun the router BGP 65000 command. And remember, customer A is only peered with the EvilCorp ISP at 172.24.1.17. And then we're going to say remote AS is 300. And so we should see that this peering comes up here shortly. So we'll put the network command, and there we go. The peering is up. So we'll say 10.3.3.0. So we're going to originate some NLRI here, 255.255.255.0. All right, so what does our BGP section look like? So show run section BGP, and that's it right there, right? So we've got router BGP 65000. We're logging neighbor changes. We've got our network command in there and our neighbor statement. So do show IP BGP is going to show us that we are learning that NLRI, which originated. And remember, when we're looking at the AS path attribute here, we're reading it in terms of originator to the autonomous system from which I learned it, and I being from the perspective of the router on which you run this command. So it originated in autonomous system 100, then came through autonomous system 300. There is no other AS path on the left side of 300, which means we are learning it directly from autonomous system 300. Remember, ISP, or autonomous system number, ASN 300 is the EvilCorp ISP. So that's who we're learning this 10.110/24 network from. We're learning it from the EvilCorp ISP. You can also see we're learning something else from the EvilCorp ISP, but this originated in the EvilCorp ISP, and we are directly learning it from the EvilCorp ISP because the only autonomous system number here is the EvilCorp ISP AS number. Okay, so that is going to conclude in terms of the BGP setup. That's going to take care of the BGP setup, but we're going to have an issue here. So let's transition back over to the International Travel Agency. So remember, the International Travel Agency is peering with the EvilCorp ISP, and EvilCorp ISP is peering with a customer. And with that customer, when we look at this, you can see that the EvilCorp ISP is passing along an update, right, an NLRI advertisement here. It's passing it along that originated in autonomous system 65,000. Now, we know from our studies that that is representative of a private autonomous system number. And so if we're sort of pretending here that the International Travel Agency is peering with a huge internet service provider, and this is the quote-unquote internet, this is going to be a problem, right? This is not good. This is bad. You should not see these ASN numbers that are private leaked onto the public internet. But this is a very, very common thing that service providers do. We work with a number of different service providers, AT&T, Verizon, and we will peer with them with BGP, and we will simply peer with them using private autonomous system numbers, because again, there's really no reason for us to have a public AS in some cases, like an MPLS L3 VPN would be in a use case that we've talked about in class, as well as a realistic use case where the provider is simply going to give you a private ASN number, and then they're either going to remove it or they're simply going to sort of override it. And so that's what we're going to take a look at now, is how do we get rid of excuse me, this private autonomous system number, which we should not have out on the internet. And so if you're following along, we're on step number 3. We're going to remove the private AS, And so I'm going to skip over the ping stuff because we've been able to ping before, and in the previous lab we looked at the pinging commands, the extended ping I should say. And keep it in mind that when you ping, remember it's sourcing from the outgoing interface in the rib. So whatever interface is the outgoing interface, that's going to be the source. So remember that sometimes you're going to want to source it from a loopback if that transit network IP is not being advertised. Okay, so we have a question here on step D. It says, why is this a problem? And we kind of just addressed that. 65,000 is a private AS. It should not be out there. So we want to either, from the Evil Corp ISP perspective, we want to ignore this, right? Or we want to simply remove it. So let's take a look at a couple ways we can address this here. So let's get onto the Evil Corp ISP. And the way that the lab is going to show us, we'll go from user exec to privilege exec into global config, and we're going to say router BGP. I believe it's 300. It'll tell us if it's not. Okay, great. So do show run section BGP. We've got that neighbor statement in there for remote AS 65,000, and that is why we're seeing that autonomous system number with NLRI originated from AS 65,000. So what we want to do is we want to remove that private AS, but we want to remove it when we're advertising from the Evil Corp ISP to the International Travel Agency. So we would simply pull up another neighbor statement. We would say 192.168.1.5, and we're simply going to say, whoops, remove private AS, right? So I hit enter here, and what is going to happen? So do we need to clear anything? Well, let's check and see. We'll come over to the International Travel Agency. Let me make sure we've got this show run section BGP. Yeah, so, and I say show IP BGP. Well, we still see 65,000, and this is one of the things, it's a good and a bad thing, right? It's good in that BGP is extremely stable, but it's a challenge in some cases where we are sort of constantly having to refresh things. Let's do a clear IP BGP star. Okay, let's see. We got an update just went out, but I don't believe that is going to be. It was. Okay, so it originated that update, and this actually happened to Robin in class, where she had made a change, went back to look things over in the lab guide, and by the time she turned back, the lab guide asked her to run a command that showed that it would be there, and it was gone, right? So it was kind of misleading, but it was just, again, the time for the update to be sent out was super close to when she was running the commands. But you can see what has changed, right? We can still see up here where 65,000 was in the autonomous system path. Now take a look at what's happening. So the private autonomous system has been removed. And again, remember, we're routing to destination. So from a path vector point of view, BGP being path vector, the International Travel Agency still has the advertisement, and it still knows the next hop, and it still knows the AS path from which it learned that NLRI. It just doesn't know where it truly originated from. But again, the other use case here, and this is probably the most common, is when you've got provider aggregatable, or PA, provider aggregatable address space, which is address space owned by the provider. And that's really probably the most common use case where you will see a private autonomous system number. Because if you don't have publicly, or I should say provider independent address space, then you can simply use provider aggregatable space, at which point you don't need to know the autonomous system number of the customer back here behind the provider, because you're going to have to come to this provider. You're going to have to come through Evil Corp ISP to get down here anyway. So the Evil Corp ISP is going to allocate provider aggregatable space, again, IP address space owned by the ISP. It'll then turn around and they'll just give you a private autonomous system number along with that provider aggregatable space, because if you don't have your own independent space, you don't need your own independent autonomous system number. You're using you're piggybacking sort of off the provider, right? And so that is where they would simply say remove private AS. All right. So we've taken care of removing that private AS. So now we're going to talk about AS path attributes, right? Or I should say an AS path filter access list. And we're going to use a filter list to apply it. Now I've got some private route servers here that we're going to take a look at because again, when we look at this here, when we talk about show IP BGP, we can use regular expressions in order to trim down the output that we're seeing. So if I wanted to see autonomous systems, or NLRI, that were originated, let's say in autonomous system 300, right? How could I do that? I could say underscore 300 $sign. So let's talk about these characters that we just used here, right? Because we're using some regular expression characters. So the underscore is being used to represent a space. Now it represents more things than just a space, but we're talking about it in the context of it represents a space, which means that if the AS path was actually like 2, 33, 300, it will pick up. This is what the underscore is matching. It would match a space, which means, again, remember, we said originated in AS 300. That means that 300 needs to be the last AS or the autonomous system number that we see on the right-hand side of the AS path. And with this AS path here, that is who we're learning it from. Again, we're pretending this is what our AS path is right now. We're learning it from Autonomous System 2. It's passing through Autonomous System 33, but it originates in Autonomous System 300. So we put the underscore to mean that there could be other spaces, right, before the 300, meaning there could be anything before the 300, but we're just matching a space. And so the space means that it could have any autonomous system number here, followed by one or more autonomous system numbers there. Then we have our AS number. And again, so the underscore and the $sign, you'll sometimes see these referred to, and I'm going to pull up a document here, you'll sometimes see these referred to as ATOM, ATOM, ATOM characters, right? So we've got the underscore, and then the $sign is an anchor, meaning the end of the path, which means nothing else comes after 300, right? That last 300, or the 300, that's it, right? And so this would match this being the originating AS. So let's go ahead and run this command and see what happens here. So let's go ahead and get the cursor back. So I say show IP BGP, regular expression 300, and that's what we end up with. So now let's change back. Let's change this back. Let's put that private autonomous system number back in there. That way we have something to compare things against. So remember, the underscore character represents a space, right? It represents more than a space, but we're talking about it as representing a space. And then let's do clear IP BGP soft so that we get back a different AS path. We'll give it a second here. And we should see that come back. And what happened on the Evil Corp ISP? Let's make sure we do show run section BGP. Let's make sure we did what we were supposed to do. Okay, we did, and we should see this is again, this is where BGP makes me nervous, as we're waiting for that NLRI coming from the customer, and yet we are not getting that. What did we see over here? And this is making me nervous. BGP always makes me nervous because it takes a while to actually update. So let's do this. Clear IP, BGP, star, inbound. So we'll clear it here on the International Travel Agency router as well. Oh, was I running the regex? I thought I was just running show IP BGP. I apologize. Yeah, there we go. I shouldn't have been so nervous. Okay. So what was happening? I thought I was running show IP BGP, but I had the regular expression command in here, which, again, so fortuitous failure, right? So I'm sitting there running the command. I'm like, where's the NLRI coming from the customer? We should be seeing that, which is this NLRI here coming through 65,000, and we weren't because I was running the command, and the reason I wanted to bring the 65,000 back into the AS path was for exactly that, to show you that in fact this command will filter out, right there, this command will filter out everything that did not originate, right? That $ anchor at the end is saying it originated in the AS300. And again, that's just a space. Now, you're probably asking yourself, okay, well, the underscore represents a space. What if I had spaces? Why can't I say that? Well, remember, when we remove the $, we're now no longer anchoring the match to the end of the AS path, right? Whereas that is clearly the end of the AS path. Let's see what happens. What do you think this is going to match? Is this going to match the first NLRI here? Is it going to match the second NLRI here, or will it match both? Or the fourth option would be, does it not match anything? But we're pretty confident that it's going to match something. So the question is, does it match the first, the second, or both? And there you go. It matches both, because what we're saying here is that it doesn't have to be the originating AS, because again, there's no $ here. We have an underscore, which means, and we talked about how the underscore can represent more than just the space, right? Because again, that's kind of the end of the line. But in this context, it's not going to match just an LRI that originated from Autonomous System 300. It matches anything that is passing through Autonomous System 300, right? Or the path contains Autonomous System 300. So if 300 is in the Autonomous System path anywhere, including the only Autonomous System number that we see, this would match that, underscore ASN number underscore. And that's different from underscore 300 or underscore ASN number $. The $ anchors it, excuse me, anchors it so that it must be the originating AS, that there can't be anything after the Autonomous System number. So now you're probably wondering, well, what if you drop the underscore there? What if it's just underscore 300? What does that mean? Well, this means that it can pass through any Autonomous System number that starts with a 3, followed by a 0, and then anything after it, right? And so let's transition over to, and I'll clarify anything after it here, when we transition over to some of these route servers, right? So I really like using the Optus BGP route server down in Sydney, Australia. So here we go. So now, again, we go from sort of a very simple example to when I say show IP BGP, whoops, show IP BGP, right? So now we get a little more complex. As you can clearly see over here, we've got the AS path attributes for the NLRI. And again, when we looked at this in class, right, we took this very first one here in class, and we saw that we've got 1, 2, 3, 4, 5 different paths to get to this NLRI. However, that path has been selected as best. So let's start there real quickly. Let's talk about this one more time. So show IP BGP, and we're going to say 1.0.4.0/24. And this is a little better format here in class. It kind of wrapped around the screen. And this gives us an opportunity, again, to walk through the BGP best path selection algorithm, right? So let's talk about this first NLRI before we transition over to the AS path and the filter list that we're going to be, the AS path access list and the filter list we're going to be using. So again, remember, what is the number one criteria, right? Number one is weight. The Cisco proprietary non-AS path, WEIGHT, weight is number one. Number two is local preference. So again, real quickly here, we'll look through. Do you see the weight set? Remember, if you don't see the word weight here in the attributes, it's not set, which means it's a default of 0. And again, these are being learned. You can see external, 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 external. So the weight will be 0 by default unless we change that. Number 2 is local pref. Right, so we come to local preference. So we look here at the local preference value. What do we see? 100, 100, 100, 100, and 100. So again, local preference is a push. By default, it's 100. The third is if it is locally originated. Well, we know that it's not locally originated. So we'll put local origination. I'll just put local. Then we come down to number 4, which is the AS path. Now this is interesting, right? Because we look at this, we've got 5 different ways to get there. However, 1, 2, 3, 4 AS paths there. So all 5 paths to get to this NLRI are passing through exactly 4 autonomous system numbers. And so what does that mean? And lowest is best, right? But we've got a push here because the value that we're seeing is 4, and that is across all 5 of the paths. So again, we look at the weight, we look at the local preference, we see that those things are all going to be a push. We see those things are all going to be a push. So we get down to number 5. So when we talk about the 5th selection criteria after AS path, we're going to be interested in what? What is the 5th criteria that we're going to be looking at here? Is it the origin code? Is it the med value? What do you think? Exactly. We're going to be taking a look excuse me, at the origin code. So when we come over to the origin code, we see origin code IGP. And again, what does that origin mean? Well, again, it means it was originated with what? The network statement. So the origin code is the same for all 5. And again, I'm having a senior moment here. Give me a second. I want to confirm that that is the case. Let's pull up our BGP best path selection algorithm Cisco. And there's our PDF. Let me double check this. It never hurts to double check. Yeah, origin code. Okay, good. For some reason I was thinking that I may have been off there. So we've got the origin code. And we'll slide up here. All right, let's pull back the output here. So we've got the origin code, and then the origin code was going to be followed by what? Well, if we flash back real quickly, you can see it's going to be the med value. So when we look here, what do we see? Whoops, what do we see set? So this actually has, remember, med, higher is better. So metric of 20, okay, that's the first path, right? Or I'm sorry, is that the second path? Metric of 20. Yeah, so we've got this metric of 20 here. Number 5, the best is number 2. And our best was where? I went right by it. So this was the best here. So you can see that we've got the metric value of 20 here. Is there a metric set here? So no, number 2 has no metric set. What about the third path? The third path does not have the metric value set. The fourth path has a metric of 20. This has a metric of 10. I'm sorry, I said metric is higher, but lower is better with the metric. So we've got the first path has 20. You've got the third path with no metric set, which means it's 0. The second path has no metric set, meaning it's 0. You've got a metric of 20 here, and then a metric of 10 here, meaning that these two both have the same metric value, right? They both have a metric of 0. And if you did a show IP BGP on the NLRI, as we've just done here, you'll remember, if you don't see a metric value listed, it means that the metric is 0. All right, so we've just looked at the med value. Well, after med, what do we have to look at? Well, we have to prefer eBGP over iBGP. So when we come back over here, we take a look and we see, whoops, we see, is it externally learned or is it internally learned? And you can see that both 2 and 3 are external, right? So again, the metric values were the same, and now we're looking at whether or not it was internally or learned from an iBGP peer as opposed to an eBGP peer. And these are both eBGP peers. So let's transition back over. Let's go down one more step, right? And it says prefer the path with the lowest IGP metric to the BGP next hop and continue even if best path is already selected. It says when both paths are external, which is what they were, which one was received first? The oldest one. And so it looks like that's where we end up here on this, is that this one right here, this second one, which is why it was selected as the best, which would be this one right here, put it underneath the community string that are being set, that this is best because it was received before that one, right? All right, so let's clear the screen here and let's get back to that AS path conversation. Whoops, we got disconnected. Okay, so let's take a look. We say show IP BGP. Let's take a look. You can see it's a little more complex here in terms of the examples that we're going to be looking at now with those regular expression characters. So we'll start with some simple examples. So that originated, right? So we want to see, what if I were to say, show me all of the NLRI that originated in autonomous system number 3477? Well, I would say show IP BGP regex, standing for regular expression, and again, just originated in, so that we could have a space after the 3477, but I anchor it, right, with those two atom characters. It gets anchored with a $sign. So I'll hit enter, and you can see it's going to take a little more time here because I think this Australian server's probably got close to 600,000 routes in it. But here we go. Take a look. As you can clearly see, we're only seeing the NLRI that originated in 3477. You see that there? Only originated in autonomous system number 3477. So we should expect to see with that command, show IP BGP regex underscore 3477 $sign, that the first or the rightmost autonomous system number will always be in this output here because of that command, will always be 3477. In fact, that's it. Okay, so there we go. So that is everything. Okay, so if that's everything for that one, what about just, let's say, any NLRI that has passed through autonomous system number 3477. So now we say show IP BGP regex underscore 3477 underscore. And let's see what we get back here from the route server. All right, we've got some good examples here that we can take a look at, and so that's all of them there. Right now, remember, we said passes through. Well, if it originates, that means it passes through that ASN. It came from that ASN, but look here. So here's a case where 3477 is not the originating autonomous system number. It's not the rightmost. It's just simply in the path somewhere. And here it just shows up. You can see it happens to show up second. Shows up second here as well. Let's see, it originates at second, originate. So again, this is where if you were to simply be looking for any NLRI that we are receiving, that we have to go through autonomous system 3477 to get to. So let's take a look real quickly here at, whoops, I'm on the wrong page there. And that's not what we want. So if you were to Google, and we're talking about the regular expression characters, if you were to Google Cisco IOS Terminal Services Configuration Guide 12.2, you'll run upon this document. You can download it. It's a phenomenal document. But what it does is it goes over all of the regular expression characters that you can use. Now, we're not going to walk through all of these, but here are, and again, I think it was referred to as the atom character somewhere in here. But here's the $sign character. Now this matches the character or null string at the end of an input string, right? So $0123 $, is going to match 0123, but not 1234, because again, that $, is saying, hey, I'm anchoring this to the end of the line, or the end of the string is probably the more technically accurate way to say that. Now the caret does just the opposite. It matches or anchors the input string to the beginning of the line. So when I say caret 123, that's going to match 1234, but not 0. So nothing can come before the 1, the 2, and the 3. So let's run these over here and let's take a look. So if I were to say show IP BGP regular expression caret 123, and again, remember, we're anchoring, and actually we may not end up with what we're looking for, because I think, let's do this. Let it run. There we go. So let's do this. We'll say caret 74. Now, this proves a very important point. When we say caret 74, that means I'm looking for the string that starts at the beginning of the line, right? So at the beginning of the string, I'm looking for the character 7, followed by the character 4, followed by anything, right? Because I don't have anything else anchoring it here. So I'm just trying to match the beginning of the string, which is right, that space that's right there. That's the beginning of the string, and then 7 and 4. So if I match those three things, I match that NLRI, which is why it's matching 7, 4, and then all this other junk after it, right? Now, if I put the underscore here, that changes things significantly, because the underscore, remember, that represents a space. So if I put the underscore in, and let's do that. If I put the underscore in, and let's say show IP BGP regex, oh, we had that right, I'm sorry, caret 74 underscore, am I going to match all of these that start with 7474? No, in fact, unless I'm peering with directly peering with AS74, it's not going to match, right? So when we come back over to sort of our original setup here on the International Travel Agency, and I say show IP BGP regex caret 300 underscore, what does that match? It matches both of these, because again, remember, there's our beginning of the string, and then 300, but it also matches that because we've got that underscore in there saying space. So now this begs the question, okay, well, I don't want to see all that other extraneous information. And let me actually transition, just trying to switch back here to the route server. What if you only wanted to see NLRI that you're learning from a direct peer, you're peered directly with the AS? Well, we would say show IP BGP regex 7474 $. And what that means is the only autonomous system number that can be in this path is 7474. And take a look there. Now, also take a look at something else that's also quite interesting. Remember, we said in the context of the course, out here in the origin code column, we would see the I, which means originated with the network statement. We would see the question mark, meaning that it was redistributed into BGP. And I said that we would not see the E. But lo and behold, here it is out on this route server. So this NLRI here for the 59.154, right, as you can see here, oh, I'm sorry, I'm not including that one. So these two NLRI right here, where did it originate, right? Did it originate with a network statement? No. This is indicating that it originated from the routing protocol EGP when we have this E out here. But remember from the previous video, it might not mean that it's running EGP as the routing protocol, this AS7474, that is giving this information or originating this information. It probably didn't originate from EGP, but remember, what can we do? With a route map, I can set the origin, right? So I can set the origin from the advertisement, so I could, or when I receive it even, I can set the origin to the E for EGP, the external gateway protocol, the actual routing protocol. So here's an example where you do actually see the E out here, but just know that on the internet, on the public internet, EGP is not actually powering or routing traffic on the public internet, at least not that I'm aware of. But we do get the chance to see the E here. So again, that's the regular expression that we just looked at, which is the caret ASN number, $ means only show me NLRI that I'm learning from this directly connected BGP peer. So again, if we come back over here, what would that look like? Am I going to see 1? So caret $300, is this going to show me the NLRI that we're learning from the customer, the 10330? No, because again, we've anchored it, and that's when you're using these atom characters, sometimes you'll hear them referred to as meta characters. It calls anchoring, especially these two right here. We're anchoring this autonomous system number to the start of the string as well as the end of the string, meaning that is the only thing in this string that I'm going to try to match. Okay, so let's go ahead. Again, you've got a good start there with some of those characters, and I can't recommend highly enough practicing out here on the route servers, because again, remember, the route servers, and that's not what I wanted, and hopefully that is going to crash out here in a second. Yeah, so when you say show IP BGP, this is a great place to practice. I mean, what a rich environment in terms of AS paths to come in and take a look at and work with. And as you can see, I'm looking for, I think there's some longer ones that are out there here. Let's see if we can't find any. These all seem to be 5, 6, and 7. Oh, there we go. We just ran by one, right? So you can see here, it looks like there may be a little AS path pre-pending taking place, a topic that we talked about last week. And again, we're possibly pre-pending 45528 is pre-pending its own autonomous system number in order to make one path look less attractive than another path. In fact, we see here for the 125, what are we looking at there? I guess we're looking at this one here. You can see it looks like there was some AS path pre-pending that was taking place here. Okay, so definitely take a look at those route servers, and let me go ahead and iconify this. So now we're going to be working with our use case here. And so this is sort of the final setup here. We're going to be filtering out using an AS path access list. And again, this is a BGP specific approach that we're taking. If you're wondering why didn't we see this with OSPF or EIGRP, the reason is that the AS path access lists are a BGP feature, right? All right, so let's get on to the Evil Corp ISP here. And what we're going to do is we're going to, they're asking us to basically filter out, let's make sure I got this right here. We are going to be filtering out Autonomous System 100. Okay, and Autonomous System 100, I need to refresh my memory here, is the International Travel Agency. So it looks like we're going to be filtering it to the customer so that the customer doesn't receive any of the NLRI from AS100. At least that's what I think we're going to be doing. Let's take a look here as we go through. So in order to filter out Autonomous System 100, we create what's called an IP AS path access list. So in other words, it's simply an access list that instead of using prefixes, right, we're going to be using the autonomous system paths. And again, we give it a number, just like we do with a regular numbered access list, 1 through 500. So let's go ahead, we'll use 500. So we'll say AS path access list 500. What are we going to do? Remember, we're going to deny, but we only want to deny autonomous system or NLRI that originated from our direct peer here, Autonomous System 100, where that, because what we're saying here, I shouldn't say originated, so where Autonomous System number 100 is the only AS path, or the only autonomous system number in the path. So not only did it originate there, but it's our direct neighbor, right? And the reason I want to be careful when I say originated there is if we didn't have that greater than sign and we had an underscore, remember, it could have been that it originated there, but it's passing through a whole bunch. So this statement right here says that it is we are directly peering with AS100. So all NLRI that we are learning from the direct peering with Autonomous System 100, that is what we're going to deny. Now, the AS path access list, just like a route map, a prefix list, a regular access list, has that implicit deny all at the end. So we have to catch, and this is where we're going to see another sort of tricky way to represent something, period asterisk. And what the period asterisk means, the period means match any one character, and the asterisk means 0 or more occurrences, right? So think of the asterisk as, again, a wild card, which means I'm going to match 0 or more occurrences of any character. So that period asterisk means match everything or match anything. And so this is sort of your permit any. So instead of saying permit any, we say permit period asterisk. And that's going to allow everything else to come through. Right? So now what we're going to do is, and that's exactly what we're doing, is we're actually going to go into router BGP 300, and we're going to prevent any NLRI, we're going to filter it out going to the customer autonomous system number. So 172.24.1.18, and this is where we say filter list. And what does the filter list take as its argument? There you go. It takes the number of the AS path access list that we were using. So we apply, we got to do the direction, right? What direction are we going to apply it in? Is this going to be an inbound filter? Again, on the neighbor statement to the customer A, we're looking at that in the outbound direction. So we're going to filter this in the outbound direction towards customer A. Again, we're filtering out. Let's look at customer A here real quickly before we transition. We're going to say show IP BGP. So we're going to be filtering out any NLRI that originated, right, in Autonomous System 100. And again, it's from the perspective of the customer, which means it originated in 100. Because from the ISP's perspective, that command that we ran earlier, or the command that the AS path access list command that we put in, this is saying that not only did it originate in AS100, but that for our peering, right, it's the perspective of the router on which we've configured this AS path access list. This means that it is the only autonomous system number in the AS path 100. So we'll say 500 out. So if I come over here, what do you think? Are we going to see it already taking effect? No, remember, this is BGP, and I'm making sure that I'm only running the show IP BGP command, and don't have a regex on there. So, and you could check this, right? That AS path access list, I could take a look and see if I were to say show IP BGP regex and do caret $100, what would that AS path access list match? Right? It doesn't match anything here, but if we're saying it originated in Autonomous System 100, oh, did it? Let me guess. Did it clip it out as I was trying to run those? It did. Boy, BGP, not my friend this morning. So as I was running these commands here, right, this one should not have matched anything, but that one should have returned the AS path. However, we had BGP behind the scenes had sabotaged my video here because it had already applied the update, right, from the update had been applied and the change had taken place on the Evil Corp ISP being truly evil. So when I ran that command right there, we should have seen this, and we didn't. We saw nothing because the update had taken effect. In between me running those two commands that quickly, it had changed. So, but bottom line is, when we take a look at this, that 10.111.0/24, the NLRI, are we now receiving that update? We're not, right? Because we've applied the AS path access list via the filter list, which again, remember, that is a BGP specific thing, that AS path access list being used in combination with the filter list. So the first video, we saw the distribute list and how we could pick off individual NLRI using an access list. Again, filtering based on the NLRI using a distribute list. Here we're seeing how we can filter the NLRI, but not based on the NLRI, but literally based on an autonomous system number. Right? So again, we can prevent or allow things based off the autonomous system number. We can prevent or allow NLRI based on the NLRI. And this is how you really apply policy in BGP. Again, definitely recommend taking a look over this document here. It walks through all kinds of different examples and things like that. It talks about more than just with the AS path. It talks about your multipliers, right? The asterisk not being an atom character, but being a multiplier, right? Because this means the number of occurrences including none. So 0 or more occurrences of the letter A. And then the following pattern requires that at least one letter be present. So that's the plus, meaning that it doesn't match 0 A's. It has to match at least one A, right? And then it gets in, these can get absolutely crazy. And there's your anchoring, right? The term that I used earlier, the anchoring characters, the caret and the dollar sign. We're anchoring the beginning of the line, we're anchoring, or I should say the beginning of the string, and we're anchoring the end of the string. You hear me saying line, and the reason you keep hearing me say line is because typically Unix, Linux, and when we're talking about matching things with regular expressions, you're looking at a line of text on which you're trying to match, but it's within the context of these characters here that it's a string that you're trying to match. All right, well, this is going to wrap up the tutorial on Lab 7-2. Hopefully this has cleared up the concept of filtering with autonomous system numbers using the AS path access lists and the filter list. We also talked about the remove private AS, which you see done, and then again that AS override, and I need to dig that up because typically in an MPLS L3 VPN scenario, that's where you're going to see the provider is going to do AS override in some cases. All right, thanks so much for watching, and I will see you guys tomorrow night.